In this video, what I would like to do is go through EQ and filters. I cannot stress enough that in these lectures, I really want to have you write down all keywords and just understand also the visual, the types of filters and the EQs that I'll be going through in this lecture. Anything that's on the bottom that says keywords or any sort of visuals that I'm getting, feel free to do a screenshot, or if you want to draw them in, that's up to you. So in the first sense, what I want to do is just go through exactly what the definition of EQ is, and then I want to move on to what a filter is. So let's just look at this first area just in here. So basically, every sound or every instrument has certain energy at a variety of different frequencies. And what an EQ will do is it will either increase or it will decrease those individual frequencies or amplitude of those sounds across what they call a frequency spectrum. Basically, this large box here is the frequency spectrum, and basically it covers all frequencies that humans can hear, from these lower points into 20 hertz up to 20,000 hertz or 20 kilohertz. Now, getting into filters now. Filters are a little bit like an EQ, but usually what you find with filters is that they're usually at, for example, this lower end of the spectrum, or they also could be found at the higher end of these spectrums. And basically what a filter is that it will do one of two things. It will either attenuate, and what that means is lower, or what it'll do is it'll boost, and that will raise a certain frequency. Again, what I said earlier in the lecture is that I do want all these keywords written down in their definitions. On this slide, what I would like to do is go over graphs. And this is important because on most of the tests that you'll have, it's going to ask you about the x-axis, which is going horizontal, and also the y-axis, which is going up and down, or vertical. So within this, let's just have a look at the x-axis. So the x-axis, which is again from this horizontal axis here, ranges from frequencies going from 20 hertz, which is the lowest that we can hear, up to 20,000 hertz or 20 kilohertz. This is going to be your x-axis, and this will always represent frequency. Okay. The next axis that we have is the y-axis, which again is the vertical one, which is going from up and down here. And again, what that represents is volume or decibels. Now, one thing I do want to mention about this graph that we do find a lot of times is on the x-axis, you sometimes will see this 10 to the power of 2, 10 to the power of 3, and 10 to the power of 4. Basically, what this means is if you did 10 times 10, well, that would equal 100. So in other words, this first frequency here equals to 100, and then this would equal to 1,000, and this would equal to 10,000 or 10 kilohertz. And that's sometimes you see this on a graph. What I want to do now is go over the 4 different types of filters that we're going to see. These are called pass filters, shelving filters, notch filters, and also bell filters. So within this slide, what I want to do is just talk a little bit about what they call pass filters. And as you can see by the name, what it's going to do is it's going to allow in either low frequencies or high frequencies through this filter. So let me just have a first look at this one, this LPF. LPF stands for a low pass filter. What this basically means is on the x-axis, which again is your frequency, what you've got is a filter which is going to cut out certain frequencies. So as you can see in this, basically all of this is being cut out. There is no frequency beyond 1K. So this is going to allow only low frequencies to pass through, hence why it's called a low pass filter or an LPF. Not to confuse you, but you can also sometimes see this as a high cut filter, but it's the exact same thing. So if we now move on to the high pass filter, the high pass filter does the exact same thing. Again, on the x-axis, you have frequencies. These are your low frequencies here. These are your mid frequencies here, and these are your high frequencies here. What this will do is this high pass filter will allow high frequencies to pass through and low frequencies to be cut. So again, where the low frequencies are, which are down here, everything is being cut out of this. So one thing to mention about this is that filters, these pass filters, will only allow certain frequencies to pass through, hence why their name is called a pass filter. So this is another example of a pass filter, but I wanted to get into some definitions about what cutoff and what roll-off mean. So first of all, let's just have a look at cutoff. Cutoff is basically the area in the frequency spectrum, and again, frequency is always on the x-axis, where you're going to start to cut frequencies. So your cutoff point is where you're going to start cutting your frequencies. Now, how much or how fast that you want to cut these frequencies, so these two areas here, are where roll-off comes into play. So as you can see that there are two different types of roll-offs here, but that basically you have one that is going to be very, very fast and not allow a lot of frequencies through, and the other one is going to be more gentle and it will allow more frequencies to pass through. There are two different types of roll-off. One is called a 12 dB, which as you can see from here, is going to be just a little bit longer than your 48, and then your 48 dB, which is going to be quite fast all the way down there. Now, to look at another one, so this is a high-pass filter, and I just want to go over this again. Cutoff is basically where your frequencies are going to begin to be cut off. So as you can guess, everything from here is going to be cut off, okay? And what the roll-off will do, and there are two types of roll-off, there's 12 dB, and then there's also 48 dB. And this is the difference about how quickly that these frequencies are going to be cut off. A 12 has more of a slope, and 48 will go right down. The next type of filters that we're going to have are what they call shelf filters. And shelf filters are a little bit different. So in the first sense, what you're going to see about these shelving filters is they are going to allow some frequencies to pass through. So unlike the low cut or the high pass filters that we've seen in the previous examples, where they cut out all sound, these, as you can see, are going to let some pass through. So what's very important you to understand is that the horizontal line, this line here, will allow some frequencies to pass through. So that is one of the main differences in a shelf filter than a pass filter. It is important that you understand about this slope, and this is basically how this curve here, and also just about this definition about what gain. And again, gain is the y-axis, which is here, either cutting, attenuating, or boosting certain frequencies. Same thing goes for a high shelf filter. So again, just notice that I'm going to be boosting this area in here, and these are my high frequencies. It's the same thing though, that you basically have some frequencies that are going to be passing through this, even though I do have a high shelf. What you may use this for is like a vocal, for example, that you want to, like boost maybe these high areas in there. That's what this is mainly for. And again, the main thing to take away from this is that a shelving filter will allow certain frequencies to pass through, whereas a passing filter will not. Okay, so a Bell filter. So the purpose of this, there are two purposes for this really. One of them is to boost your frequencies. So as you can see here at 4K, I've got a Bell filter, and basically what this will do is this will boost these sounds or these this instrument, in this example at 4 kilohertz. Another area that you can get into is attenuating or cutting out. Now, what's very important here to understand is, again, with this, you still have those sounds that are going to be passing through. And we'll get into the next one in a second. One thing I do want to mention is this Q value. So this is very, very important. Q value basically is the width. So it's this arrow here and this arrow there. It's the width of this bevel filter, or how wide it's going to be, and you can adjust this in an EQ. Finally, what we have is a notch filter. Now, a notch filter will completely take out all sounds. So as you can see from this, that basically what this is going to do is it's going to take out all these sounds here. Nothing will pass through within this here. So what you'll have is either side of this. So this will pass through and this will pass through, but the middle part won't. And again, just go over that Q value, or that width value again. The whole purpose of this, and I can't stress enough, is going to be to attenuate certain frequencies. So hypothetically speaking, let's just say that you've got a like a ringing in a vocal part, where you can use this notch filter, which is also called a band reject filter. And what you can do is you can take out certain frequencies. Now, I want to repeat myself, which is all these keywords need to be written down, as well as the visuals and definitions, because you will be tested on this. If there are any questions on this, do let me know.